Welcome back to Low Stress Math with Mrs. Bono. We are on Unit 7, Transformations, page 35, a review of dilations. So, let's step into it. Here we go. A dilation, and the symbol for dilation is a capital D, is the process of enlarging or reducing an image. Dilations have the same shape as the original figure, but a different size. Dilations create similar figures. And remember, similar figures have the same angles and the sides are in proportion. And we're going to talk a little bit about scale factor and how to find scale factor, but mostly let's just do this. The coordinate plane graph this triangle. Well, let's just write the coordinates on here as we go. A is at -1, -3. B is at 3, -1. 3, -3. And C is at 1, 1. And that's the same triangle we had earlier. Now we're doing a dilation with a scale factor of 2. Scale factor of 2. And scale factor, remember we were using script F equals 2. So we're going to multiply 2 times every one of these numbers to get the new triangle. So the thing about dilations is in order to keep it the same shape, you have to multiply every number times the same scale factor. So it would be 2 times -1 and 2 times -3. And 2 times 3 and 2 times -3. Now, before I go any further, I'm going to ask you a question. I want you to start thinking. Is this going to get bigger or smaller? If the scale factor is 2, is it enlargement or reduction? Think about it. You know the answer. Yeah, that's right. It's going to get bigger. It's an enlargement. So 2 times 1 and 2 times 1. And that's going to give us the new A prime at -2, -6. And B prime at 2 times 3 is 6. 2 times -3 is -6. And C prime at 2 times 1 is 2. 2 times 1 is 2. Okay, so let's come over here and graph it. A prime at -2, -6. 1, 2, 3, 4, 5, 6. Here's my A prime. B prime at +6, 2, 4, 6, -6, 2, 4, 6 down here. And A is at, C is at +2, +2. There's my C prime. So connect the dots, make a nice enlarged triangle, bigger than the original. So there it is. Da, da, da. And it's lovely. Now if you want to just double check that you did it right, you can do it quickly in your head. Because remember, scale factor, the scale factor is going to be equal to the image over the pre-image. So we could actually count the boxes between A prime and B prime to get this length. 1, 2, 3, 4, 5, 6, 7, 8. So my image length is 8. And my pre-image up here from A to B is 1, 2, 3, 4. So my scale factor, 8 divided by 4, is 2. So I get the same scale factor. So I know I did it correctly. And you could do this bit in your head, but I was just checking it. All right, now I'm going to come over here and I'm going to change something, because this has a dilation with a scale factor A. I would prefer that to be scale factor F for, factor and consistency. Now, it really doesn't matter what letter you're using, but I prefer to use, get on there, the F for the factor. So that's what I'm going to do. I am going to change that to, really wishing my whiteout was working. That's what I should change it to. Happier whiteout, to an F. So parentheses F. So it should be the factor times X and the factor times Y. So what are the rules? Multiply the scale factor times, oh my goodness, look at this. I wrote X and X. And you guys were just going to let me get away with that? Really? Come on. You know I make mistakes. You have to correct me. Oh, wait, you can't correct me over a video. That can only happen in person. All right, so we are multiplying, and make it look like a big dot here, Bono. Multiplying the scale factor times each coordinate. So multiply the scale factor times each coordinate. Okay, so down here, my scale factor is 3. So I'm going to multiply 3 times X and 3 times Y. So the X is first, the Y is second. So 3 times 3 and 3 times 5. 3 times 3, 9, 3 times 5, 15. Well, that makes sense. Make it a little smaller so you can see the whole thing. Slide that up in. Given the image of a point, negative 416 under a dilation with a scale factor of 1/2. So I'm starting with X is negative 4 and Y is 16. And a scale factor of 1/2. That means I'm going to multiply 1/2 times negative 4 and 1/2 times 16. And you remember when we were talking about multiplying by a fraction is the same, well, multiplying by 1/2 is the same as dividing by 2. So negative 4 times 1/2 is negative 2. You just divide it by 2. So negative 2, and 16 times 1/2 is 8. Right? Now my dilation down here is negative 4, so I have to multiply negative 4 times both of the coordinates. So negative 4 times negative 3, negative 4 times 5. Negative times negative, positive 12. Negative times positive, negative 20. Now I'm using a scale factor of 1/3, and that's very much like 1/2. So I am going to divide by 3, because multiplying by 1/3 is the same as dividing by 3. So 1/3 times 3 and 1/3 times negative 6. 1/3 times 3, well, that's 1, because 3 divided by 3 is 1. Negative 6 divided by 3, negative 2. So my point is at 1, negative 2. Okay, here's my scale factor is 4. So 4 times negative 3 and 4 times 5. 4 times negative 3, negative 12. 4 times 5, positive 20. All right, and oh, look at this, big cheats. They didn't give me the scale factor, but I am a little smarter than that. So remember how you find scale factor? It's the image, this is image, over pre-image. Remember, pre means before, so pre-image. So I have to divide to find that. Image over pre-image. Here we go. Image, and I have, well, -1 over pre-image, which is +2. So now I know my scale factor is -1/2. I could have done the other coordinate. These were the x coordinates. I could have used the y coordinates because -2 divided by 4 is the same -1/2. So either way, you would get the same scale factor. And the last one, D2, I don't know what x and y are. So I could divide by the scale factor and find out what that is, because the opposite of multiplying, well, let's just write it down. Well, 2 times x equals 4, and 2 times y equals 2. All right? So divide by 2, and x equals 2. Divide by 2, and y equals 1. So my coordinate is 2, 1. All right, not too bad. Take care. I will talk to you soon. Bye.